I wanted to share as a case study some of the accomplishments of a program funded by the National Science Foundation, which is part of the scholarships in science, technology, engineering, and mathematics, because this serves as a case study for this idea of capacity building in STEM with an emphasis on modeling. Our program is called Preparation of the Data-Driven Mathematical Scientists for the Workforce. This doesn't mean that we're producing data scientists. However, this has meant that our students have been very involved with versions of this schematic here. Okay, so the original target of the program was to fund 30 students. And I'm listing here in this table terms. These are academic terms. These are excuse me. So I'm going to read you something that somebody's sharing here, but I'll read it in a minute. I'll read you something that somebody's sharing on the live feed in just a minute. So academic terms, thank you, are basically semesters. So that was the original design of this. 6 semesters with scholarship funding, and then there would be 30 students. Well, we started the program, and as it happens, this is the theoretical concept, and as you start implementing this, you start learning, first-hand knowledge. And so it so happened that we did fund as many as 12 students with over 6 terms, but then we have a number of other students that would have shorter length of funding, 4 terms, 3 terms. Most of these are semesters, but there have been summer sessions also that are included, considered an academic term. Okay, so even though we've had different students with different lengths of funding, we have managed so far to fund as many as 55. Even though our original number was 30 students, we have funded 55 students so far. So in my role as a director of this program, I have also been principal investigator for similar programs of capacity building with emphasis in undergraduate research funded by the Tennessee Board of Regents and funded by the National Security Agency. I would say that, thank you, that if I were going to mention the factors that are important for creating undergraduate programs and overseeing that they become successful, I would say definitely you have recruitment, then you have retention, then you have graduation, and then you have job placement. So I think as somebody that would design or be an architect of creating undergraduate programs, I would consider all those factors. And certainly this type of funding could be a recruiting tool for bringing talent to our university, bringing full-time students to complete undergraduate degrees in STEM. In a way, some people probably have opinions about explaining this. This is my own opinion. This type of funding is like paid time for students. They have to work less outside of school, and then they can invest more of their time in professional growth and improvement of technical skill proficiencies. Another thing of our STEM program is that even though this program doesn't have as one of the goals to inject undergraduate research, those experiences have been important for some of our participants. This program has provided a bridge to some of our students who were successful in landing opportunities, paid internships, or paid REUs, research experiences for undergraduates, outside of ETSU during the summer. And those experiences outside of the home institution, they have been very influential in paving the way to continue graduate studies or to launch certain career paths. And this is another opinion of mine, that not all experiences outside of the home institution, not all experiences are great. Some students in the summer, they go to do research in a lab, to do research in, sometimes it's to work in a company or something during the summer. When they come back, they say it was terrible. It was actually, sometimes it's terrible, sometimes it's not so great, Most of the time, it is a good experience, In my opinion, good or bad, these experiences outside of the home institution could be very valuable in terms of triggering graduation. Students usually become, when it's a good experience, they come back to the home institution very motivated, and for them, they have expanded their horizons. There is a light at the end of the tunnel. They work really hard in making sure they graduate within the expected timeline.
Question, Aryan.
Yeah.
So I hadn't thought of this before. I just did some calculations when showing the previous slide. One calculation is that if you had gone according to the original model, that would have been 30 times 6, which is 180 semesters of support. But in this way, with different levels of support, I calculated it has actually been more than that. It's 189, unless I made some slight mistake. That's one thing. Secondly, the business of paid time, it is not insignificant. The amount, I think, was 5,500 times 3 years.
Yeah.
And
so
that equates to about 20 hours at $10 an hour per year. And per year, it would be for 30 weeks a year, right? 30 weeks a year times 20 is 600 hours times $10 is 6,000, which is what we're talking about.
Mm-hmm.
So this really amounts to a 20 hours a week job for 3 years. So it's significant.
It's significant.
It's much more than what I'd realized, actually.
Yeah, it's one way of I think there are some people that have some feelings about how you phrase this. But to me, that's how I explain it to the participants, and I do it for all reasons. I give them a letter of acceptance and I spell out, basically, if you are part of this program, you need to think of this as a job. When you get sick and you don't show up to work, you have to call, you have to, say, I won't be there today because of, so I try to work with them in creating this sense of ownership, because I think it's for most of them that complete the program, due to a number of factors, they're very good at following guidelines, following deadlines, making commitments. And part of that mindset, I think, is very, very valuable, So in a way, I also explain to them there are duties here or expectations similar to those of a job. And let's remember that you're getting paid. You're getting paid to acquire some proficiencies, some technical proficiencies. So out of 55 students, this is kind of the breakup. Almost they divide in half. Half of them are students with a single major, mathematics is a single major, and the other half are a mixture of students that are majoring in a STEM discipline that is not mathematics, computing, chemistry, biology, physics, engineering, technology, and health sciences. Now, some students are actually, I think they are exceptions. I don't know how they're doing this, because when I was an undergrad, to me it was enough with having just one major, right? But there is a group of them that have dual majors, mathematics and computing, mathematics and physics, and mathematics and chemistry. So this is another way of looking at the diversity of disciplines in our program. And also another way of reviewing that, we've managed to, in the last year, in the last 18 months of the program, there have been nearly 20 out of the 55 that were recruited, right? So out of the count of 55, nearly 20 of them are completing the program in the last 18 months of the life cycle of the program, right? Which I think is also another significant accomplishment. So if I have to summarize to you, so what do the STEM scholars, what do they do? You talk about this mathematical modeling minor and proficiencies. Well, let me just try to do that in one slide, okay? So there is a part of the proficiencies that involves computing, okay? And for us, computing has been a mixture of very baby steps, but yet an introduction. For some of them is an early introduction. For some of them is the one and only introduction. They were never going to see this type of thing called Linux, an operating system. Then R and Python, those were things that they would pick up somehow in some of their coursework. So that's kind of like the part of that has to do with computing. And then in early years of the program, we had workshops or tutorials. One of them had to do with predictive modeling, with microarray data analysis. And then now in latter years of the program, we've managed to have this group of 20 students, basically, going through different classes that incorporate, some of these data-driven or modeling-driven goals within the coursework. So one of these classes is a class I teach. It's called Mathematical Modeling. They're also going through, there's a group of 20 students that are going through math modeling, statistical machine learning, applications of statistics, and numerical analysis. Right? So this is kind of the program in a nutshell in terms of the technical proficiencies. So I mentioned that even though our program is not an undergraduate research program, and maybe that since we are in this part of the technical proficiencies, I tell you what David Curry is writing here on the live feed. I'm not sure if you can see the chat, but I would totally support R as a great solution to statistics. We use it for statistics and data mining. In a general sense, R is more flexible. Beyond statistics, it might be a good introduction to things like Linux and Python, in baby steps. That's some comment that David Curry is the person in charge of research computing. And so he has some comments there about R. So undergraduate research was not originally one of the goals of the STEM program. However, the program provided funding to bring external speakers from federal agencies and from other institutions. Sometimes these interactions, the speakers would give a public lecture here at ETSU, and then they would have a private meeting with some of our STEM participants, and that combined with some of the tutorials and workshops and some of the other active agenda we were promoting made our participants very motivated. They started applying to and were successful in landing paid internships or paid REUs in this list that I'm showing you here. So these were summer appointments, basically, summer positions. Another accomplishment is that several of our participants completed their undergraduate degree, and then they continued graduate studies. Most of the graduate studies were in either mathematics, applied mathematics, or statistics, or some combination of that, such as business analytics or data science. And these are some of the institutions where they went to. These are some of the universities where they went to. This is a mixture of master's programs or doctoral level programs. And then, even though this is a young, short program of a 5-year life cycle, some of our graduates have managed to land employment. And the list here is not as extensive as the list of the summer positions, because some of them are still in graduate school. Some of them went directly from their undergraduate studies into landing a job. Some of them did a master's. But here, this is, I think, a good example with 2 out of 4 employers here are in the federal government, and 2 of them are in the private sector. And I think certainly all these jobs that were landed by the STEM scholars, former STEM scholars, have to do with data. They're using data in some capacity.